First of all, one disclaimer, if you've seen my title and you think this isn't the one, I think at first John said, "Do you want to talk about cow size?" And I said, "No, I'm not crazy." Because my first thought on cow size is that I put it with politics and religion. So I try to only talk about it with people who already know me well enough to have decided that they like me or don't before I tell them my opinion. And some of you in here have known me a long time and probably know that's true. The other thing is that I come from a long line of seed stock producers. So the top photo is one of my great-grandfather's Shorthorns, and the bottom photo is another great-grandfather's Hereford. So I'm kind of, I have heterosis in my blood because that's from both sides. And I'll say that as I think about, cow size, one of the biggest things I think about is how bad extremes are, right? So I show this slide to beef production. The little Hereford bull, the horned Hereford bull, is one that my great-grandfather apparently thought was good enough that he spent a lot of money to get some really good pictures on him. And I'm trying to figure out who he was, but their handwriting on the back is kind of cryptic. The black heifer on the other side is a female that my family raised a couple years ago that did quite well and we think is good. Those two have some things in common, and they have some things that are very much not in common. And the critters along the way certainly were very different too, right? So we're an industry that over centuries has made a lot of changes in what we think is the perfect animal. And one of the things we've learned from that most is that anytime we make a big choice that's extreme, it's bad, right? Now, unfortunately, we as cow people aren't making the big extreme choice right now. It's someone else who's not always willing, in fact, usually isn't willing to pay us for what they want us to produce, right? That's what they do. That's what the end users try to do to the cow-calf industry. So I will mention a couple things here on cow size that isn't just that I don't want to talk about it before I talk about what I do want to talk about. And that is that as we consider cow size, I want to challenge everybody before they throw the first stone to figure out what their mature cows weigh. So I know that the cattle that I actually own part of, I only know how much they weigh when my dad gives me a cull cow check. And I go, whoa, A, they're worth a lot, like Dr. Wiegand said, and B, she was bigger than I thought, right? I weigh cows almost every day in my real life, though. Tomorrow morning at 7 a.m., that is what we will be doing, is weighing some pregnant cows. And I know that my favorite cows on study, my favorite cows to use, weigh 1,350 to 1,400 going into late pregnancy on average. The best critters from that weigh a lot more. You know why? Because they have muscle. So your cows weigh probably more than you think they do if you don't weigh them a lot, or your customers' cattle weigh more than they think they do, because your breed still has muscle in it. That's why we like them, right? One of the many reasons. And so remember that not all weight is equal. So do we know how big our cows are? And also, what is size in terms of a factory? So this kind of gets me into what I'm going to talk about a lot. I think of cows as factories. They're my favorite factories. They're my favorite substance on the planet. But this cow, her job is to hang around for a long time and make as many products or calves as she can, right? When we think in terms of a factory, we don't necessarily think that a big factory that makes a lot is a bad thing, right? It depends what we're making, for sure. But also, a factory isn't just determined by the size of the building, it's also determined by what's going on inside of it, right? So as we consider this factory, we need to know that every time we add any weight on her, she does need more nutrients. I'm a nutritionist, and so that's, a thing that we know. But also, every time she has more of some of the useful stuff, like things that actually help her get nutrients to her calf, including things that act as reservoirs, which muscle does. So muscle ends up being this place that you can put extra protein, right? We can't store protein anywhere in our body. But when we're hungry, and cows go through periods of their life when they don't get enough nutrients, even though we're trying, when they don't have enough nutrients, they can pull from their muscle and they can pull from their guts and their other body proteins, and they can give their little fetus or their udder amino acids that come from those, and those are really good sources of them. My least favorite research cows are the little light muscled ones, because you know what I can't do? I can't stress them very much. I had a couple that came onto a study recently that I looked at them and said, if I nutrient restrict you, you might die. And so she automatically, especially this one, she got put onto the control group because I didn't want her to die. I needed her as a number. That is something we need to consider as we go on a war against cow size. I'm in the middle of the road on this, but I think that cows can get way too little, just as they can get way too big. And sometimes right now we're on a war about the too big, not as much as we could be about too little. So now we're gonna get more into this cow as a factory and talk about how to manage her to make the calf we want. So we know that she has a goal to make this product, right? I have a heifer calf up here because I'm a cow-calf person, and I don't really care as much about the terminal critter unless I'm eating it. I'm gonna be really honest about it. But regardless of what that product is, we know that she's gotta get nutrients to it and that she is completely beholden on the weather, as we all know. We know that our weather's pretty volatile right now. That is not a picture of drought conditions from this summer in the map. That's, I think, last summer or the summer before. Actually, I think it's 23. Anybody here in Missouri knows the last 2 summers were terrible, right? And this summer feels like a gift from heaven. Except that even when we got all of this rain, it turns out a lot of our fescue right now is terrible. There's mounds of it, but it grew so much that it's mostly fiber and doesn't have a lot of protein in it. And so we have to keep in mind that this cow regularly is in situations in which she is stressed in the amount of nutrients she gets. And yet, you all have been working to make her genetics give her the potential to do so much. And her calf have the genetics to have the potential to do so much. And it can only do that if it has nutrients. So her job as a factory is to give nutrients to her calf. And the only period of the calf's life that she can do that is from the time it's conceived until the time it's weaned. It is not her problem after being weaned, right? It's someone else's problem then. But in this time, she's got to get nutrients to it. And for it to meet its genetic potential, it has to have inputs to do that, right? You all know this. You all know that when you sell cattle, there are buyers that you do everything you can to block from getting the good ones. Because you know if they buy the good bull, he will never, ever, ever make it through his first breeding season. Or if they buy your good heifer, she will look like a dog at the end of the year, right? You know that. So we have to keep that in mind when it comes to the cow, that she needs inputs to make this great product, because we're not trying to make chicken. We can't feed cows chicken feed and expect that if we're not feeding them well, we're asking them to do so much and we give them nothing, they can't make the products that we need. And so that's going to be really what we're going to talk about today. Now, a disclaimer, because I don't want to offend anybody. I'm a purebred cattle person. And sometimes when I say things like this to purebred people, I make them mad. I know that most of you actually do a great job managing cows. C-stock people do, purebred people do. However, you've got a bunch of customers who may not. And we're currently dealing with really weird conditions, right? So sometimes we think that our forage is great. And many people, maybe even in this room, have genetic information on every animal on the place, but haven't done a hay test in decades. You don't have to identify yourself. But I want you to ask yourself, do I have harvested forage? Have I tested it? If you have not, that is the best $50 inflation. I used to say $25. But that is the best $50 that you can spend between now and when you start to feed it. No questions asked. Because it turns out you can't look at hay and say it's good, right? Think about it like, EPDs. Not every hay bale that looks good actually has the right numbers. Not every, show bull that looks good has good EPDs, right? So we do actually have to keep in mind that even some of us maybe can do a little bit better job. I'll also say that I know that many times when we don't feed cows well, it's on accident. And so I'm not casting blame on this situation, but I want us to think about the nutrients a calf needs from the time it's conceived until the time that it's weaned. And that's pretty much what this figure shows. I'm a scientist, and so this is what I think about going on in a calf during that time. What my lab really does, and what I'm going to talk to you about primarily today, is what's happening in late pregnancy. So we really study everything in gold, and that's mostly because we really focus there on late pregnancy and what it does in the later periods, because fetal growth, or that calf's growth before it's born, is really increasing here in late pregnancy. While it's increasing in late pregnancy, that means that the cow needs more nutrients to give to it, right? The problem with that is that we've actually selected calving seasons primarily to give more nutrients to that cow actually when she's making milk, right? And when we need to get her rebred, which means that many times she doesn't have as much of an opportunity to eat as many nutrients when she's in her late pregnancy. Unfortunately, between weaning and calving, in many situations, we say, nah, she's got this under control. I don't need to worry about her until a couple weeks before she calves. And so sometimes we also imagine that when she's full and she's got a big fetus in her and she's round, that she's got a little more condition on her than she does, and she calves and deflates, and we start to count ribs or spinous processes, and we realize that things went badly. At that point, we've already kind of messed some stuff up. The problem is that when we put her in a situation like that where we don't give her enough to eat as much as she wants, she has to make choices. Her body has to make choices. Cows aren't thinking about this, of course. But while they're pregnant, there's really 3 places they're sending nutrients. The green parts themselves, they've got to maintain themselves. They're the factory. That's really important. We should not be mad at cows who prioritize taking care of themselves, because we want them to be a factory, right? But we also know that their product is what we're going to sell this year. We don't want to sell the cow this year. And so they're going to send nutrients to their fetus now, but they also have to send some nutrients to their udder. Why their udder during pregnancy? Because if they're a heifer, they're trying to, form it for the first time. If they're not a heifer, they have to reform it every year, and they also have to make colostrum. So when we mess that up, if we don't give her enough nutrients, then we definitely have to consider that she's not going to be able to send all the nutrients to each of the places, and she has to make some choices. Now, we know that cows generally pull from themselves first. They're kind of the ultimate martyr, but there's a limit because they need to keep themselves alive. It is bad for their calf if they are dead, right? Or if they can't make milk. And so they do start to limit then their calf and their ability to make milk, which is what I'm going to talk to you about. So I'm not going to show you as much data as I would like to, because I could talk about these data for hours. But I'm going to show you just a few data points from a recent USDA-funded study that we have in our lab, and just kind of explain quickly what's going on. I'm going to use the mouse here so that you can see it a little bit better. If you take a look here, essentially we took heifers that were pretty similar breeding. Here in the first experiment, they were all single-sired heifers bred to a single sire. In the second experiment, a couple more sires for the heifers' dams, but only one for the calves. All fall calving heifers. Essentially, for the last 120 days of their pregnancy, we fed them to either meet their protein and energy needs, or we fed them 70% of that. After they calved, we fed them to meet their protein and energy needs. And so this is what it kind of looked like here at the bottom. This was our goal for their energy intake. This gray line are the controls. They always got what we projected that they needed. And that was for their maintenance and their growth and their pregnancy or lactation. This gold line is the nutrient-restricted group. And so, again, they didn't get to eat enough during late pregnancy, and then we brought them back up. Essentially, we did this by feeding them individually. So it's a Kaling gate system. They wear a necklace around their neck. They're in a group setting, but they only can eat out of one gate. This first experiment, we kept them around for a long time, and we really focused on what those calves were doing. And the second one, we were a little heartless here at calving. We pulled the calves off, and we actually slaughtered them at 48 hours of age so that we could learn more about what was going on with some of their tissues. So I'm not going to belabor everything that happened, but I want to show you that I know how to starve cows. I think it's an important thing to show. Not everybody does. It's a talent. But essentially, we could make these girls way thinner if we nutrient restricted them. So the gold line, those heifers calved at about 2 condition scores lighter, and 140 pounds post-calving lighter. So they were heifers, they should have been growing, and rather than growing, they actually stopped some growth, they grew skeletally, and they pulled their own fat and muscle. Despite this, we had and the same thing happened really in both experiments with that. We had a different response depending on the study in what happened to the birth weight of their calves. So in general, when you don't give a cow enough to eat, you expect that she's probably going to short her calf. And especially when you see 2 body condition scores come off of them in 120 days, that's what you expect. The second experiment read the hypothesis, they did what we expected, and they made calves that were smaller. However, the first experiment, I made this a different pattern than usual. What I want to mention here for a minute is why this decreased birth weight's bad. Now, I think you probably know this, but if you don't, or if you need a new way to think about it, I want everybody to be on the same page. Because I know that when I told my dad I was trying to increase birth weights in calves in grad school, he pretty much said, "What the hell is wrong with you?" And so I know some of you might be thinking that. Here's the problem with decreased birth weight. If this is how a calf wanted to grow, that's its genetic potential. We understand genetic potential, right? We think it's good. If we have them be smaller at birth because we didn't give them enough groceries to grow to their genetic potential, we've changed their growth trajectory. Why is that bad? Well, if we change fetal growth trajectory, bad things can happen. So we can change fetal development and their vigor and their cold tolerance and all kinds of things like that. You don't like it when you hear that someone had a 4-pound baby human, right? You think that's a bad thing. So when I hear that someone had a 50-pound calf and they're bragging about it, I'm like, ooh, yeah, I'm not so sure I'm on the same page as you, especially if they thought that it was supposed to be 65 pounds. So my take-home message, if you remember nothing else that I said, I want you to remember this. We change birth weight with genetics, not nutrition. You can change it with nutrition, but you're going to mess up a bunch of stuff. And you actually cannot feed birth weight into a calf that its genetics didn't have the potential for. The only way that I know that you can put too much birth weight into a calf actually is if you first grow it in a dish. If it's produced in vitro, large offspring syndrome's a thing, but we actually can't give a cow too much protein and make her calves too big. If that's ever happened to you, that means that your cows weren't eating enough to begin with, is really what the data would say. So now I'm going to come back to this. First experiment, we changed birth weight. That was what we expected. Second experiment, we didn't. Why? Because cows are amazing, and their biology, and they're frustrating, and they don't always follow the rules. However, this is what happens in the real world. Sometimes we feed cows less, and they actually sacrifice completely of themselves so that they can give it to their offspring. And every way we measured these calves, they were similar. However, they didn't act similar. So again, if you follow the red dot here, essentially what we do is we're really interested in understanding how early calves especially are affected, and so we're interested in their vigor. Best way to measure it in many ways is just to see how long it takes them to attempt to stand and actually stand. And we found that if the dams were nutrient restricted, in this study, the one where they weren't different size at birth, they took longer to attempt to stand and longer to stand. Now, they were born in the fall in Missouri, so understand that that's really August and September. It was hot. It was not cold. And so this would have probably been a lot more dramatic and a lot more detrimental if they had been born in January. And I've lived a lot of cold places, and I'll say that there's a lot of calves that would have been in a world of hurt in this situation. Now, after that, again, remember they were the same size at birth in this experiment, because I'm only going to follow the ones that we didn't kill. We found that while they only had access to milk because they were in that Kaelin gate system with their mamas, they couldn't actually get to their mother's diet. They diverged with their body weight really quickly. So their body weight by only 42 days of age was different. And by the time we took them out of that system, they weighed about 15% less. When they then got access to the hay that their dams were eating in large dry lots, they still weighed 13% less at weaning. So this certainly could be because of how we treated them, as fetuses, the nutrients they got there. But I'm going to show you their mother's milk production here in a second, and you'll see why why I think that's going on. Something just to keep in mind in case you're thinking, they're just smaller, no big deal, Allison. We actually changed their skeletal size by the time they were 2 months of age. Their ribeye areas were different. Now, those calves had some catch-up growth after we weaned them, but if you're selling them at weaning, there is quite a bit of growth that you gave up from these calves, and there's a lot of ways that their growth during this period was probably affected. So we didn't really study their muscle fibers, but we probably messed those up and made it more difficult for them to actually be calves that succeeded making it all the way to 1,600 pounds. Now, part of the reason that that happened most likely is because they had less groceries. So the cows, now cows, previous heifers, they made less colostrum and they made less milk. Now keep in mind, they were eating their requirements. The females, after they calved, all were put on the same diet. And so they were getting enough protein and energy at that point, but they still couldn't make enough milk. And of course, if they can't make enough milk, they have smaller calves. I'll also point out that the control calves in this study were not growing as much as they could have. These are not tremendously high milking animals. I know that's 4-hour milk yields. I should have grabbed the daily milk yields for you that we calculated. But these are not high milking heifers. They're really average. And so I'm not showing you, the crazy old high milking dual purpose sort of Simmental's. Not at all. So, we've talked about what happens with the calf. I'm actually a lot more interested in the factory in a lot of ways, as you can probably tell. I love the cows. And so one of the things we wanted to ask is what happens to them for the rest of their lives? So again, just to set you up a little bit for this study, we couldn't follow them the rest of their lives based on money and the other things that are needed to really do that. But we got this money from the Illinois Beef Association to really ask what happened during their second parity, so their second pregnancy and lactation. So again, these grays are the controls, the golds are the previous nutrient restricted. And what we found is that even though we'd been managing them together since we weaned their first calf, and really we were feeding them similarly since they gave birth to their first calf, that they still were smaller if they had been nutrient restricted in the first pregnancy. They weighed less throughout their second pregnancy, the rest of their second pregnancy, and their second lactation. Down here at day 216 is when we weaned their second calf. They also had lower body condition. And so there's some, pros and cons to some of this. As we think about it, here are my big questions. You might say, hey, Allison, I really love the idea of stunting growth in these heifers. Did you decrease mature cow size? Their heights are the same. They're 7 years old now, the ones that have remained in the herd, and their heights are actually still on average very similar. However, I think we decreased muscle mass. So my eye says, I've got some livestock evaluation background too, my eye says that those girls have less muscle, and I don't think that's what they intended to be. The problem with less muscle, of course, is that they don't have as many reserves, and we also don't think that they have as much fat. So when we measured even their back fat in their second lactation, it was still lower. So we think we've kind of changed their set point of how many extra stores they want to have. That could be good. That could be bad in a drought. This is a really hardy group of females that has stayed in the herd pretty well, and so they're kind of unicorns. We actually are currently looking for money to ask this question again in a little bigger way and with a little more of a mechanistic lens. But it's important to keep in mind that what we do to a heifer, especially during her first pregnancy and lactation, does affect her forever. So we expect her to grow about 20% of her mature body weight while she's pregnant. But many times we think she's developed because she's pregnant. And I think that's really wrong. I think we need to consider that she's still being developed all the way through her first pregnancy and probably until we've weaned her first calf. Now I want to shift gears just for a couple of minutes here to calves. So we know we're at a really low point in the cattle cycle, right? We know that we have fewer beef cows right now in the U.S. than we had any time since the 60s. This is not good in many of our estimations, even if we like the high prices that we get for our heifers and our cull cows. The thing about that is it means there's a place for every calf that's born, and every calf, the moment it comes out alive, is worth a stupid amount of money, right? Like, have you looked at what week-old calves are worth? It's kind of insane, even if they're, I would call, only half alive, right? They're worth a lot of money. Now, right now, how we're making up for the difference between how many calves the feedlots want and how many they have is with beef on dairy, which is fine, but I don't think that we want to miss the opportunity to take advantage of being able to make more money from calves. One of the clearest ways that we can make sure that calves don't meet their genetic potential is to have them die. So dead calves can't meet their genetic potential, right? If they're dead before you want them to be dead. I mean, at some point, they should probably be dead, especially if they're terminal. But you following me here? Death is bad as a baby. And the problem is that neonatal calves are the ones that are most likely to die. So I think more than 5 to 6% of beef calves die. I think that this survey data is well underestimated. Not saying that more of yours die, but more of other people's die for sure. And what little data we have about when calves die say that 2/3 of their death happens in their first 3 weeks of life. Their first 3 weeks are tough, and there's a lot of things that really factor into that. Now, as someone who messes with pregnant cows, calving cows, baby calves all the time and gets chased a lot and cusses a lot, I know you all are probably similar too. We know there's a reason that a lot of people don't want to mess with these animals a ton, but they're worth so much money. I think we need to ask ourselves, can we manage cows to do a better job of providing their calves what they need so that they can make it through this difficult period? One of the things that those cows do that's really important is they make colostrum. Now, it's hard to study colostrum in beef cows because there's a lot of factors that are challenging. But what we've learned is we have, when we just take one of their single rear quarters and we collect all of their colostrum, is that there's a lot of variation in how much colostrum cows make, even if you keep other things similar. And so what I'm going to end here with is a more practical data set maybe than my nutrient restriction that's very academic and, individually fed, very intensive. And that's just this data set where we've got about 250, 260 cows in this. These actually were all managed what we thought was about meeting their requirements or exceeding, sometimes by my lab, sometimes by the farm crew. And then at calving, we collected data. We essentially put them into these two buckets. We said they're adequate. So the black bar, that they were a body condition score between 5 and 6.5. We don't have many above 6.5, but I kicked them out if they were a little too fleshy at calving. And that's, of course, where you see most of them fell. But there were still about 80 that were at a body condition score less than 5. The average is a 4.5. I'll tell you most of them were 4s to like 4.75s with a couple of the scorers. What we can see here is that if they were thin at calving, and we don't know why they were thin at calving, they may have lost condition in late pregnancy, they may have the previous lactation, they may have 3 years ago. We don't know in this sort of data set because we weren't purposefully restricting them, remember? If they were thin at calving, they made about 44% less colostrum. So that's pretty similar to what it was in our more intensive data set. Now, this isn't going to mean a ton to a lot of people, so I'm just going to tell you what I take from this. Calves need nutrients, and they're in a really tough spot because they don't have many that they're born with, and they're completely reliant on the cow while they are often cold or hot, right? Because we don't calve cows in nursery or in hospitals and put them in nurseries or warm beds like we do humans. They don't have heat lamps like pigs. And so when we see something where calves have less circulating glucose or less circulating fat when they're young, that shows that they had a really easy chance of slipping into not having enough nutrients. And so these are all fall-born calves. We weren't cold stressing them, but they had lower blood glucose and lower blood triglycerides if their dams had been thin. So that means that their bodies could be saying, I don't have enough nutrients, and maybe not giving enough nutrients to their immune cells and letting them get scours or letting something else bad happen to them. So even if they live, they don't starve, they could be hurt for the rest of their lives. So big picture, does this calf have enough inputs to meet its genetic potential? And if it doesn't, what happens? Now, again, I'm not someone who studies their muscle. I'm not a meat scientist at all. That's what Dr. Regan does. But I think we need to keep in mind that if we don't give them enough inputs when they're fetuses and when they're young calves, we can very easily change their muscle fibers. Sometimes as a fetus, we can change their muscle fiber number, but many times we're changing the size, and that can be a problem. We can easily change carcass weight, but maybe more importantly in some ways, as we think about a lot of the challenges of the industry, as we push them to go farther in time and in weight, as Brian said, it's easier for them to fall apart. The wheels can come off the bus if it's on the road longer, and so their mortality and their morbidity can easily be higher based on some of the things that happen to them much earlier in their life. And so one of the things that I really want you to think about is that we don't necessarily have to make cows bigger to make their calves have the potential to be bigger. We can just manage them better so that their calves can meet their genetic potential to do those things. Now, I do have a little last soapbox I want to get on for a moment, if you'll indulge me, and that is that we do need to consider, as Brian was talking about, calving ease and birth weight selection. I have a little even harder take on it than him because I think some of our calving ease selection is not making cows have bigger pelvises, and it is just making all of the calves smaller. And I'll say that when we decrease size by making calves have less muscle fibers at birth, we are not setting them up to be the carcass that currently packers want. But also when they have short gestation lengths, they have issues sometimes with survival and vigor, and their mother's having enough colostrum and all these other things. And so I don't think that your breed is the one that's doing the most damage right now, but certainly we probably have really gotten into a new extreme that some people are talking about, but a lot aren't willing to because we know that we don't want to help cows when they calve. I'll just tell you that, a long time ago, Cal Farrell, who retired from the Animal Research Center, said that it's difficult for fetuses to meet their genetic potential for growth because there's so many ways a cow can mess it up. I often now am not sure that's the case because we've made it so that they don't grow when they're a fetus. And that's a really important developmental window. And so if we push them too far in that direction, we're also causing some real harm in my mind. So with that, my take-home message is we do have to manage that calf from the time it's conceived to meet its genetic potential if we want it to. And what's the point of having great genetics if you don't realize the genetic potential because you didn't give it the inputs it needed? Now, I'm team environment. There's a bunch of people here that are team genetics. I think genetics matter a lot, but you do need to give them the groceries to do it. So with that, I know that we're going to be on a panel later, and I am excited to hear more about what everyone's thinking in this area. Thank you.